So yeah, thank you to Anna and all the other organizers. It's a pleasure to be here. You can tell by my accent that I'm not based in the European Union. I'm in fact based in Canada, so it's nice to connect with a bunch of folks from a different market, but who are working on the same problem. So I'm here with Carbon Engineering. We're another company like Climeworks who has been working on direct air capture of CO2 for the past decade plus. And we've developed a wet scrubbing technology that's kind of complementary to the solid sorbent technology that Climeworks has, but fundamentally we're going after the same problem. We'd like the ability to absorb industrial scale quantities of CO2 from atmospheric air and to provide those in a purified and compressed format where they can be either used to make products or to deliver carbon dioxide removal, both of which with the goal of reducing our total net emissions. So we're talking a lot about definitions and what's what. So I copied this image probably from somebody who's on this call recently because I really liked it. In terms of looking at climate as a geochemical problem and the notion of moving carbon around from long-lived stores like the fossil geosphere to much more active stocks of carbon in the atmosphere, the biosphere, and the oceans. So I thought I would just try to clarify what we're aiming to accomplish at Carbon Engineering on this type of map, and say that we're working on direct air capture for fuel synthesis. This is something we call air to fuels, where we combine captured atmospheric CO2 and renewably produced hydrogen manufactured from renewable electricity, and we thermocatalytically combine the CO2 and the hydrogen to make liquid hydrocarbon carriers that are cleaner burning, have a lower life cycle carbon footprint than conventional fuels, and are also compatible ideally with today's downstream fuels infrastructure and engines to avoid the infrastructure turnover required to use such products like hydrogen in its raw form. The other, of course, just to sort of clarify acronyms and terms, the other thing we're working on is direct air capture coupled with geological sequestration. We're rather agnostic as to whether that sequestration is done into basaltic formations like have been mentioned today, or sedimentary formations, so long as it's quantifiable and permanent. And obviously we've got a lot of experience doing sedimentary CO2 injection in North America, so no surprise, that's what the early projects that will use our technology are likely to do. So we're working with Occidental Petroleum and their joint venture called 1.5. They have licensed our DAC technology to start deploying facilities in the US Permian Basin, where there's a lot of existing infrastructure to transport and inject CO2, where historically that has been done for enhanced oil recovery purposes, but where many players are starting to realize that if that CO2 is supplanted with anthropogenic or atmospheric CO2, then they can start to alter the carbon balance of those activities, and they can repurpose some of those formations, some of those pipelines, some of those wells, and even drill into new saline formations to do dedicated standalone carbon sequestration. So the rendering you see there is a plant that's in feed engineering now. We're about 50 or 60,000 man hours of engineering into this facility that's going to be built out in 2 phases to accomplish about 1 million tons of atmospheric carbon dioxide capture per year. So that's the equivalent to 250,000 cars or 40 million trees. So meant to be operable at very, very large scale. And we and others are going after these opportunities in regulated markets. So I've got a couple of revenue stacks on the screen here that show the type of policy instruments that direct air capture facilities can earn within North America. So on the left-hand side is a hypothetical revenue stack that is, and the top might be available in coming years to direct air capture facilities, where so long as you can apply and prove to the California Air Resources Board regulator that you're quantifying your net atmospheric tons injected and sequestered, and so long as you can prove to them that you pass their permanence protocol, then you can generate California LCFS credits. So that's the bottom of the left-hand stack, and those are worth about $200 per ton in today's market. And then similarly, if you apply to the US EPA and register a monitoring, reporting, and verification plan with them, then you're eligible to generate 45Q tax credits from the US federal government. So the 50 per ton that's shown on the screen is already in place, and then the expansion up to 120 is something that is contemplated in Washington and subject of active legislation, but not yet implemented. So similarly here in Canada, on the right-hand side of the stack there, we have a clean fuel standard, much like the California program, though it is still in design, not implemented. And our government just 2 weeks ago announced the intent to design and implement an investment tax credit for point source carbon capture and direct air capture. So that's not done either, but that's in design. So the takeaway here is that we have sort of, multi-hundreds of dollars per ton of revenue potentially available from regulated markets and regulated policy instruments in North America. And hence we're starting to see the proliferation of point source CCS projects and direct air capture projects. So just a couple thoughts from carbon engineering perspective on how direct air capture and its uses can play a role in decarbonization, and maybe some of the policy ideas for getting this rolling in the European Union as well. So I think everybody's probably familiar with curves like this. It's an abatement cost curve, and it just says that the first tons we can go out and reduce are much, much easier than the last tons, or the middle tons for that matter. And we have to do them all, as many people have made the case today. So fundamentally, the way we see carbon dioxide removal, and I'm talking about direct air capture on the slide here, because of course it's what we work on, but I think this is true of all forms of physical permanent carbon dioxide removal, is that they cap the cost of reaching deep decarbonization and net zero. Where we can reduce tonnage more cheaply and more efficiently today, let's go do it. But when we get to tons that are too difficult or too costly to do with the technologies we have at our hands today or a few years from now, let's start using large-scale physical carbon removal to pull those tons back and save expenditure. So I think how does this influence our thinking in a policy perspective? I think what we would say is that there's a lot of different sectors with very different cost bases for emissions reductions, and thus different sectors have different values that they would be willing to place on carbon dioxide removal. So on the left there, those are sort of broad. The left set of stacks there are representative pricing for markets that are broad and cover a wide variety of industries. So one example is the California cap and trade. It's been operating for a long time. Pricing's really well established. It's about $20 a ton, and that covers power and some of the other industrial sectors in California. On the right-hand side, you've got markets that cover transportation only. And again, to run with the California example, I mentioned already that LCFS credits trade at $200 per ton. But if you sell eligible low carbon intensity fuels in California, you don't only generate LCFS credits, you also generate federal RFS RINs. And when you stack those two values together, you're actually up in several $100s per ton. These are market mechanisms, so these prices are actually reflecting the costs of decarbonization. And my point here is that they're very, very different. So I think in terms of pulling direct air capture and other forms of carbon dioxide removal into the marketplace, I think just to throw a few thoughts out, we see a couple of different options. One is to include carbon removal in the high value markets, the high value narrow markets that we know can benefit from it today. Another is to include carbon dioxide removal in the more broad but lower value markets today, but with some kind of contract for difference, to bring the pricing and the revenue that is available in those markets up to the levels that we know are needed to support the various forms of carbon dioxide removal. One way to think about doing that is that you're prepaying to have a larger carbon dioxide removal industry available at your fingertips as you really start to need it when you're going up the more challenging tons of this abatement cost curve. So the taxpayer or the public is paying to this contract for difference in order to get a carbon removal industry formed and going so that it's commercially available at very large scale when we get to harder tons. The third is just to have sort of standalone independent thinking and to design policy instruments that incentivize and make financeable revenue streams available for carbon removal proponents in and of their own right. So these could include such things as a government choosing to directly procure carbon removal to counteract a set of their own emissions, or other things such as the carbon take back obligation. So I think I'll wrap just really quickly because this is about certification of carbon removal after all. And I think I'll just, in the interest of time, I'll just very, very briefly say there's been a lot of work done on certification in North America. California Air Resources Board laid out a very detailed CCS protocol with a list of criteria that span the characterization of your geology and your injection infrastructure through to your project operation and then eventual reservoir closure and long-term liability after your project ends. And the US EPA has very, very detailed guidelines for geologic sequestration of CO2 as well. So I think there are tools and there are policy frameworks that have been developed to calculate and quantify and certify the kind of physical carbon removals that hinge on geological sequestration. And I think a lot of that work lends itself to what we all have to do in new markets, including both regulated and the ever evolving and ever changing voluntary market as well. So thanks again.